Good morning, everyone. The very final example of yesterday's lesson dealing with integration by parts was asking us to find the integral of e to the x sine x. And what we learned from that example is we had to perform integration by parts twice. And when we finally did that, we ended up with this expression. And then the idea was that since this is what we're trying to determine, and we have the exact same term over here and it's negative, then we could add that term on the right to the term on the left to get 2 multiplied by the integral that we're after equals e to the x sine x minus e to the x cos x, and then we divided by 2 to get the answer. So this is a very similar idea to what you're going to have to do when you complete the final problem in your final assessment. The only thing that makes the problem in your assessment more difficult is there are coefficients in front of the x, and there is also a coefficient in front of the integrand. So what I said was I would upload a video showing an example similar to that. And the only thing that's going to make this a lot trickier are all of those coefficients are going to start to accumulate and give us bigger and bigger numbers that we're going to have to deal with. You have 2 options here right out of the gate. One of the things you could do is take that 7/8 out and write 7 over 8 multiplied by the integral of e to the 3x cosine of 5x dx. And then what you could do is focus your attention on this integral. In other words, ignore the 7/8. Do integration by parts twice with this integral, and then multiply the result by 7/8. I'm not really sure that it's going to make that much of a difference, because as we go through the layers of integration by parts, we're going to be building up coefficients anyway. However, I am going to choose to do this. I'm going to keep the 7/8 out, and I'm only going to focus my attention on the integral that I've highlighted in blue. Of course, you run the risk at the end of all of this of forgetting to put that 7/8 back in. So I'm going to have to choose u, and I'm going to use the component of the integrand that's trigonometric as u. I'm going to have to differentiate that to get du. The rest of the integrand I have to choose as dv, which means dv is e to the 3x dx, and of course I have to anti-differentiate that to get v. So the derivative of cosine of 5x is negative sine of 5x, and then multiplied by 5. The antiderivative of e to the 3x would be 1/3 e to the 3x. So this integral of e to the 3x cosine 5x dx is equal to uv. I think everybody's probably got the hang of this already, but I'll continue to highlight how we integrate by parts. So it's uv minus the integral of v du. uv would be 1/3 e to the 3x cosine of 5x, and then minus the integral of v du, which would be negative 5/3 e to the 3x sine 5x dx. And of course, I can factor that negative out of the integrand and write it in front as a sum. That's going to give me the integral of e to the 3x cos 5x dx equals 1/3 multiplied by e to the 3x multiplied by cosine of 5x plus the integral of 5/3 e to the 3x sine 5x dx. Now, under most circumstances, I would recommend taking that 5/3 and putting it outside of the integral. I'm going to write this down, but then I'm going to erase it. So if you take that 5/3 out, then you will end up having that integral, but that integral, everybody, is going to be a uv minus an integral v du. And if we are doing our job properly, what we are going to discover is that this integral here will be the same as this integral here, and we're going to have to combine those integrals by moving that integral on the right to the left, just like we did with the example yesterday, so that we could have one integral with a coefficient. So if you take that 5/3 out, you're still going to have to multiply it through at some point anyway. So my advice to you is don't bother writing that 5/3 outside. Okay, now we're going to apply integration by parts to the integral that's on the right. I'm going to choose u equals sine of 5x. Remember my advice from yesterday and earlier today in this short video, that if you choose the trigonometric part as u in the first round of integration by parts, continue to use the trigonometric component for the second part. If I choose sine of 5x for u, that means dv must be everything else, which is 5/3 e to the 3x dx. Now, I told you that it was my idea to keep that 5/3 in. You didn't have to do that. When you do your own example, whatever number is there, you can factor it out if you like and deal with it later. Or you could put it in front of the exponential component like I've done, or you could write it in front of the trigonometric component. I could have written u equals 5/3 sine of 5x, and then just had for dv e to the 3x. Regardless, I have to differentiate du. It's going to be equal to cosine of 5x multiplied by 5, which is 5 cosine 5x dx. I need to anti-differentiate 5/3 e to the 3x to get v, and that's going to give me 5/9 e to the 3x. So again, we are going to use integration by parts by looking at the formula. The formula says this integral will be equal to the product of these minus the integral of the product of v and du. So now we are going to have the integral of e to the 3x cosine 5x dx is being equal to 1/3 e to the 3x cosine 5x, then plus uv minus integral v du. Well, uv will be 5/9 e to the 3x sine 5x minus the integral of v du, which is going to be 5/9 e to the 3x times 5 cos 5x dx, and that's going to give us 25/9 e to the 3x cos 5x dx. Now, in the next step, we can worry about moving that coefficient of the integrand, 25/9, out in front, because we're going to need to know what that number is, and I will explain why that's the case in just a minute. All I'm going to do in this next step is remove the brackets. I'm going to have the integral of e to the 3x multiplied by cosine of 5x dx, and it's equal to the following three terms added together. 1/3 e to the 3x cos 5x plus 5/9 e to the 3x sine 5x minus 25 ninths multiplied by the integral of e to the 3x cosine 5x dx. And looking at the line above what I just wrote, I realize now I didn't need that set of brackets because I wasn't subtracting, I was adding. However, I like to put them anyway. So where do we go from here? Well, this is the idea that we stumbled onto yesterday in the final example. We noticed that this, which is what I'm trying to find, I'm trying to determine what the integral of e to the 3x cos 5x dx is. It also appears over here. So what is in yellow is what I'm after. It's not my final answer because I don't know if you recall, but I decided to take a coefficient out of the whole thing to begin with. But I do want to find that. I'm going to call this thing that I've highlighted in yellow, you can call it whatever you like, R. It's just a letter. The R doesn't stand for anything. But if I knew that, then I could figure out what my answer is. And I'm just going to scroll up and remind you, because our answer is going to be 7/8 multiplied by R. This thing here is the R that I've highlighted on my last line. So what we end up having is 1R on the left and negative 25/9 R on the right, which means if I add 25/9 of that to the other side, this is how many of those integrals, which is R, I'm going to get. And that's going to be equal to 1/3 multiplied by e to the 3x multiplied by cosine of 5x plus 5/9 e to the 3x sine of 5x. We can certainly figure out what 1 plus 25 over 9 is, which is the coefficient of our integral. Let's see, that would be 9 over 9 plus 25 over 9, which I believe is 34 over 9. Yep. Multiplied by this integral, which we're really curious about, because if we know what this integral is equal to, I've called it R, then we can multiply it by, I believe the number we left out from the beginning was 7/8. So this is the integral of e to the 3x cosine of 5x dx. And it's equal to 34/9 of that integral is equal to 1/3 e to the 3x cosine 5x plus 5/9 e to the 3x sine 5x. So now what I can do is worry about getting rid of that 34/9. To get rid of the 34/9, it's pretty simple. What I'm going to do is I'm going to multiply both sides of this equation by 9/34. Of course, what that leaves me with on the left-hand side is that integral that I'm after. It's not quite my final answer, but at least I will be almost there. The integral of e to the 3x multiplied by cosine of 5x dx will be equal to, now I don't know what you want to do with these numbers. I'm going to leave that 9/34 out. And then I'm going to have 1/3 e to the 3x cosine 5x plus 5/9 e to the 3x sine 5x. Remember that the answer to this problem that I've made up is 7/8 multiplied by the integral of e to the 3x cos 5x dx. Well, The integral of e to the 3x cos 5x dx is this thing on the right. So if I multiply both sides of this equation then by 7/8, I would have my answer. 7/8 multiplied by the integral of e to the 3x cosine 5x was the original question. Well, the 7/8 was inside, but it's equivalent to the original question. So I have to multiply the other side by 7/8. I'm going to have 7 over 8. Then I'm going to have multiplied by 9 over 34. I think I am going to factor out 1/9 out of this. I don't think we want fractions in our answer here inside. So if I factor 1/9 out of 1/3, I'm left with 3. You can check that because if you multiply this 3 by the 1/9, you are going to get the 1/3 that you started off with. What else do we have? I factored out the 9th, so I'm left with plus 5 e to the 3x sine 5x. I'm not quite done, so I'll worry about throwing in my constant in a little bit. So my integral of 7/8 e to the 3x cosine 5x dx equals, well, what does this work out to? Well, the 9 on the top and the bottom cancel, so I'm left with 7 on the top and 8 multiplied by 34 on the bottom. 8 multiplied by 34 is 272. Yep, that's right. And then we have 3 e to the 3x cosine 5x plus 5 e to the 3x sine 5x plus a constant. You would hate to lose half a mark here at the very end because you forgot to put plus c. So that is the answer. Now I'm being perfectly honest with you when I say I made this question up and I did not do this ahead of time. I don't know if this is right or not, but I can obviously find out because I have the whole world at my disposal. It's called the internet. I can enter in this integral somewhere online, and I think probably the best place to do that would be into Wolfram Alpha. Now what I could do is just enter the integrand and then go hunting for the antiderivative of it, but Wolfram will allow me to say integral of, and then I can type in my function. I don't know how many brackets I need here, so I'm hoping that it's intelligent enough to know what it is I'm talking about. So let's see. 7/8 e to the 3x cos of 5x dx as an integral is equal to 7 over 272, I believe that's what we had, e to the 3x, and then in brackets 5 sine 5x plus 3 cos 5x. Let's just take a peek. So what Wolfram said was the following. I think most of you can see that it's the same thing, but just for completeness sake, what Wolfram said is it's 7 over 272 e to the 3x. So Wolfram factored out the e to the 3x that was here and here. And I believe, if memory serves from just a couple of minutes ago, it also happened to write things the other way around. It wrote 5 sine 5x plus 3 cos 5x. So that's what Wolfram alpha says. I was just checking to see that they put plus c, and they do have plus the constant. So we were right. I think the thing that makes this problem so intensive, so grueling mathematically, is all of the numbers that are tagging along from line to line. So my advice to you would be to go slow, be methodical, be thoughtful from line to line, always going back and checking that you've written everything down that should be written down. It's very easy to miss something. I hope that helps. And by the way, if you're watching this video on Thursday, you still have, by my count, 10 days to get in your final assessment. I see that our school administration has sent out an email to all students saying all student work must be submitted by the 19th. The due date for this final assessment is still Monday the 22nd. But remember, if I don't get it by 3:15 on Monday the 22nd, I will not be marking it. I just do not have time to track down missing assignments. Get it in on time. You still have 10 days. I would hope that some of you have already been working on it, and I know that I've already received from somebody the completed assessment. They've figured out how to do this final question on their own. So one person has actually finished it already. There's no reason why you can't get it done on time. I hope that's helpful. Hang in there. Once you get all these final assessments done, you're done for the year. Then you can relax. And I know how much you must be looking forward to it, because I feel the same way. Once again, I really, really miss working with you guys. I wish that I were standing in front of you and we were doing this work together, but we're not, so there's no sense dwelling on it, but I just wanted to let you know how I felt. Have a great weekend if I don't talk to you before the weekend. And remember, next week we have 2 lessons, one on Monday and one on Wednesday. You take care of yourselves. Bye.